Pneumatics. As you can see here in this picture, we have 4 sources of high pressure air. The first source is from engine number 1. The second source is from engine number 2. The third source is from the APU. And the fourth source is when we provide a ground cart with high pressure air to the aircraft, externally plug it in order to be able to have high pressure to start the engines when the APU is not working. So all the four high pressure sources possibles go into this pressure manifold, or the pneumatic manifold, and then the pneumatic manifold distributes to the various users that need the air in the aircraft. That's the basic outline of it. As you can see here, we have, for power sources, we have 115 volt AC, which, because it's all high pressure air and everything, but we also have a 28 volt DC for pneumatic sources here. Possible use of the 28 volt DC there is for the purposes of emergency operations, the actual hookup with the ducts. So we've got the APU down here supplying air on the down the left hand side to the manifold by a check valve. Engine 1 supplying air, engine 2 supplying its air, and somewhere down here we have, oh, there it is, the ground connection, the fourth connection to supply the air. All these ducts are measured for over temperature in case there should be one. We have a control panel in the cockpit. This panel is a panel for an 800, the Dash 800-900. The control panel for the Dash 700, 600, 700 is a little bit different in its operation. The air conditioning system and air system are a little bit different, but the panel itself, this panel is identical. So pilots can get out of a 700 and get into an 800 and fly it without having to relearn this panel, because the operation of this panel, all the switches are the same. It's just the system differs a little bit between the smaller 737NG and the longer 737NG. Okay, we're going to go through these in detail in a minute. As we can see here, it's all the blue lines are air. Okay, and the black thin lines are electrical signals. So you can see it's a fully analog system with air from the 5th stage, so an intermediate stage of the pressure sequence of the engine, and the 9th stage, which is the high pressure, the latter area, the latter stages are the high pressure. And as you can see here, the 9th stage is the high stage valve, HP valve, which is basically an on-off valve, open-close valve, whereas the 5th stage, when the air comes here to this PRSOV, it's a pressure regulating and shutoff valve. That means this one modulates. Okay, so the idea is when you start an engine, you start with the bleed valve open to alleviate any excess build up here in the compressor section. Okay, and as the engine is up and running and above idle, okay, this valve will basically close, the HP valve, and the 5th stage, this PRSOV will modulate in accordance with what the system requires, analogically, so to speak. Okay, we also have a check valve here, as you can see, to prevent any high pressure air, because the high pressure air will win. Yeah, if there was any escape of high pressure air here because this didn't close fully or it didn't close fully, then we have high pressure air going into the lower pressure stages, and that would cause engine damage. Therefore, we have this check valve here, which is a one flow only valve to prevent that from happening. All the rest of the circuit is showing temperature control and monitoring and pressure control and monitoring to open and close valves as required to prevent over temperature and over pressure in various situations. As you can see, distribution of it is like this. So from the engines, from the 5th or 9th stage, we get air being provided, hot air for the engine starter. Here we have what they call a wing thermal anti-ice valve. Okay, this one will go to the hot air to the wings to anti-ice them. The side we're talking. So whatever I talk here for engine number 1, we have an identical circuit right down here for engine number 2. So we got hot air coming from the 5th stage is high, let's call it HP air or IP air, intermediate pressure air. High pressure air goes for engine start. High pressure air goes for the wing thermal anti-ice system. And we also have the NGS. We provide bleed air, which is enriched in nitrogen, to the nitrogen generation system to suppress any flames in the fuel system. The rest of the air goes to the left-hand engine, left-hand pack valve to go to the left-hand pack to provide air into the air conditioning system, eventually to the cabin, which is cold conditioned and pressure regulated. We also, with this hot air, pressurize the hydraulic reservoirs, and we monitor the pressure via a pressure transducer here. This is my first air provider. My second one is from engine number 2. On the right-hand side of this isolation valve, what does the isolation valve do? It closes, it crosses, it isolates basically left and right. It can also, when open, it can also join, left and right if required. Okay, or cross bleed, so to speak. Now, the first HP source, second HP source, third HP source from the APU via a check valve, so you don't have the higher pressure air going into the APU and damaging it. So we have a check valve that will go to, depending if this is open or closed. Okay, if this is closed, the isolation valve, then high pressure air this way to the left-hand pack. Or if this is open, then this one will go to the right-hand pack and the left-hand pack. So this has an important role here. And the pneumatic ground air connection is the fourth source that we connect if the APU is not starting. However, note, you have the isolation valve on this side. Therefore, if you were going to start the engine with the pneumatic air connection, look at this, we'd have this closed. Therefore, we would have to start engine number 2 first, with the high pressure air. And when the high pressure air is good, we would take the high pressure connection away. When with a running engine, we would have high pressure air now. By opening the isolation valve, we will be able to supply air to the left-hand side and through to the engine start valve to start the engine. And once this side was then self-sustaining, we could then close the isolation valve, and engine number 1 would supply its components, and engine number 2 would supply its components. That's how the normal configuration is during flight.